Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. This is part 2 of Sequences and Series, so let's go. In part 1, we saw how a sequence is represented using these curly brackets and the UN. The curly brackets because, it's a set of terms as we saw. Some textbooks also use AN. That is also acceptable. Some will also use TN, okay? The terms, all right? But that N, remember, is a subscript, all right? So each term is U1, U2, U3, and so on and so forth. And that UN is our general term. We saw this in part 1. The first term is also represented as A. Okay, that's universally A, refers to the first term of a sequence, and that is important. And this UN is the general term, the general formula that is going to define each of the terms of the sequence. In this particular video, we're going to talk about how to use that general term, how to use the general formula to evaluate some of the terms of the sequence. So this example is about finding the first 3 terms of the following sequences. Well, what do? If the general term is given to you, like this in this case, if the general term is given as u of n is 3, n plus 2, we want the first 3 terms. So n is equal to 1. Remember n, this n, set of all natural numbers, this term, okay, first term, second term, third term. So all that we do is that we replace n by 1 to get the first term. This is how it goes, all right? So n equals 1 gives us the first term, u1, which is going to be 3 times 1 plus a 2, which is 3 plus 2, and that's 5. And remember that u1, the first term, is also indicated as a, all right? That's a common notation for the first term of any sequence. A is the same thing as u of 1, which is the first term. In the same way, we can go ahead and find what the second term and the third term is going to be. And we say n equals 2 gives us the second term. u2 would be equal to 3. Replacing n by 2, we'll get 6 plus 2, that's going to be 8. And in the same way, we can go ahead and find what's going to be the third term of this particular sequence, all right? So it's defined by 3n plus 2. So we can say that u3 would be n equals 3. u3 is 3 times a 3 plus 2. And so it becomes 9 plus 2 is 11. Simple? All right, let's take another example. Here, un is given as 7 minus n squared plus 2n in the same way, okay? So now I'm going to use a, the first term, which is the same thing as u1, as we said. N is equal to 1. That's going to be 7 minus 1 square plus 2 times a 1. That's 7 minus 1 plus a 2. That's 9 minus 1 is an 8. The first term of this sequence, defined by 7 minus n squared plus 2n, is equal to 8. And in the same way, if you want to find the second term, we just say, all right, in this case, we have n equals 2. Replace n by 2, and you'll get u2, which is the second term. That's going to be 7 minus a 2 square plus a 2 times 2. You see that? Okay, so this is going to be 7 minus 4 plus a 4, and that should be just 7. And so in the same way, when we want to evaluate the third term of the sequence, we just replace n by 3. And so u3, the third term, is going to be 7 minus a 3 square plus a 2 times a 3. Okay, just replacing n by 3, you'd get 7 minus 9 plus a 6, and that's a negative 2 plus a 6, giving you the third term as 4. So those are the 3 terms. The third term is 4, the second term is 2, and the first term is 8. Okay, let's look at the third example. Here we are given u1. The first term is given to us as 1. The second term, u2, the second term is given as 1. All right, and then the general term. This is your general term. The general term, un, there's another word for it. Sometimes we refer to it as the nth term. The nth term, it's like, saying the first term, the second term, 100th term, the nth term. The general term is also referred to as the nth term. The nth term is given by this formula. Look at this formula. Can you all see this formula clearly? All right, look at this formula. It says un, any nth term, is equal to un minus 1, one term before that, plus un minus 2, 2 terms before that. That means any term, any general term, is defined in terms of the previous 2 terms. But look at this part of the formula. It says this formula is only applicable when that n is greater than or equal to 3. That means from the third term onwards, you can use this formula, not before that. Okay, so they are all natural numbers like all in the other cases. But this formula is only applicable n greater than or equal to 3, means from the third term onwards. So the first 2 terms are given to us, which means the sequence is going to look like 1. That's the first term given to us. 1, that's also the second term. Okay, the 1 and 1 is the first term, the second term. For the third term onwards, we are going to make use of this formula. And what is this formula? This formula says, well, it's the sum of the previous two terms. So for the third term, the sum of the previous two terms, 1 and 1, that should be 2. For the fourth term, the sum of the previous two terms, that means this one and this one, right? This is going to be n minus 1 for the fourth term, n minus 1, and that's n minus 2, right? So that's going to be 2 plus 1, and that's going to be 3. And then for each successive term, all right? Now, this is going to be the fifth term, right? 1, 2, 3, 4. Yeah, the fifth term is going to be the sum of these two terms, the previous two terms. That's 5. And if you look at the pattern, this is, yeah, you guessed it right. It is our famous Fibonacci sequence. This kind of a definition is what we say that the sequence is defined implicitly or defined in terms of the previous terms. And these sequences are called recursive. Recursive sequences, or it says recursive definition of the sequence, okay, because the nth term is defined in terms of the previous two terms. So these are some special definitions of sequences. And while we are at it, I just wanted to show the previous day's work where we talked about the sequence of all primes, the set of all primes. And I also made a correction, I put a ticker there that this was a mistake. This is not a prime number. So I'm just going to cut it out publicly. I want you to try it out whether the set of all primes, the sequence of all prime numbers, can be defined recursively. We just saw that today, right? What is a recursive sequence? Well, it's defined in terms of the previous one term, two term. Try and see whether you can come up with a recursive definition for the general term, the nth term, the general term for the set of all prime numbers. Okay, that'll be a good exercise. Now let's jump to the calculator and see how we can use the calculator to evaluate the general term as we did today. All right, in this video, we were talking about evaluating general terms. So you can add a calculator page, and the syntax is SEQ. All right, SEQ. All the syntax can also be found out on using the catalog key. But when you type in SEQ, you can put the parentheses, and there you can put the definition, the general term. So I'm going to use the same examples that we saw today. 3n plus 2 was the first one. I can just say 3n plus 2, and then we need to put comma and n because that's a variable, all right? And then we can say that you want these are the first 3 terms, okay? Because using the calculator, you can say for the first 10 terms. So the syntax is to be interpreted as 3n plus 2 is your general term, the general formula, the nth term as we saw today, comma n. N is the variable, all right? And then 1 to 10. Okay, when you hit enter, it'll give you in that bracket. Remember to set, the calculator recognizes. So it starts with 5, 8, 11, and that's exactly what we got, all right? 5, 8, and 11. We got 3 terms, okay? If you want to check that also, our calculations, that's 5, 8, this was 5, that was 8, that was 11. We got the 3 terms, but now that we are on the calculator, we can easily evaluate the terms, the first 10 terms of that sequence. And even if you want to generate intermediary terms, so let's say, rather than saying the first 10 terms, if you want to say, I want the terms, the third to the 7th term, right? Third to the 7th term, or you can even say 30th to the 50th term. But those values are the term number, third term to the 7th term, the lower limit to the upper limit, and that will calculate and it will generate, as you can see, that's the third term. Third term is 11 and 23 is the 7th term, okay? So that way also you can use this formula. You can also use the TI-Inspire to generate the terms of a sequence that are defined recursively, but the syntax for that is slightly different, okay? It's SEQN. For any general sequence that is defined explicitly, as opposed to a recursive sequence which is defined implicitly. Explicitly, when a sequence is defined, you just use the SEQ option, whereas the syntax for a sequence defined implicitly, SEQN, but then watch out for the syntax, okay? So first we put the recursive definition. Let's use the same thing, the one that we saw for the Fibonacci sequence. This is how it goes, okay? So you put UN minus 1, almost like a function, right? U of n minus 1, and then UN minus 2. Okay, so that is going to be the recursive definition. And now, comma, you got to put the initial values, whether that's 1 value, 2 value, but how you enter the initial value is that you got to put it into that curly bracket. And to get that, you had to hit Control and the close parenthesis key. Okay, so you'll get that curly bracket option. Our initial values were 1, 1, because that's U1 and that's U2. And the definition is in terms of the previous 2 terms, okay? And now, after that, you can say you want the 10 terms, all right? The 10 terms of the Fibonacci sequence. And when you hit enter, and that will give you the first 10 terms, okay? That's 1, 2, 3, 5, as you can see, okay? 1 plus 1 is 2, 2 plus 1 is 3, 3 and 2 is 5, so on and so forth. And those are the first 10 terms of the Fibonacci sequence. You can even do some crazy things with that, okay? If I say the first 10 terms Okay, if you add one more parameter and you say that I want the terms that are less than, if I just say 20. Okay, so this next number that I entered, I've said 10 terms, but I said they should be less than 20. And if I hit that, can you see that it's only listing those terms that are less than 20? What will happen if I just say 21? Will it list that term which says 21? Let me just quickly find that out. And I say 21, that means, that the maximum value you're looking for. Even there's, you can say 100. If I say, the first 100 terms, okay, this parameter out here is for the, how many terms of the sequence you want. And this second number that's here that says, I want every number that is less than or less than or equal. Let's see what it generates. And yes, it does list out 21, the term that's equal to 21. Which term is it? It's the 1, 2, 3, 4, 5, 6, 7, 8. Eighth term of the Fibonacci sequence is 21. It lists the eighth term also, so that parameter for the upper bound should be interpreted as less than or equal to and not just strictly less than. Okay, so I hope that this video is useful to you to understand how to evaluate the general term of any sequence and how you can use the calculator to list the terms when it is defined implicitly or explicitly. I'm going to see you all in the next video.